Guys, welcome to week 7 of distance learning. This is part 2, piecing together Pangaea. So I'm going to walk you through what this looks like because it could be a little bit challenging for some of you. And then that way you can hopefully get an idea for what you're supposed to do this week. So you've already done part 1. So you looked at fossil evidence and you've started to figure out what the world might have looked like at that point in time based on the evidence that we have. And then this is what you're going to be doing next. So we have those same 5 fossils. Actually, they're not exactly the same, but they are 5 fossils of different species that existed and that lived on different continents during a certain period of time. And what you're going to do is use these index fossils to match up the continents and figure out how they were arranged way back when these species were alive. This was all in the Mesozoic, which was a while ago. So you're going to do this on the next slide. So I'm going to show you what that looks like. Hi, guys. So for the next slide, this is how you're going to do it. So you can click on it. You'll see that the name and the country are actually 2 separate pieces, but we group them together. So what you're going to be looking for is this little stick right here. When you click on the little blue dot, then you can actually use it to rotate the countries. And essentially what you want to do is rotate them to match up these different puzzle pieces. So on this slide, we told you guys exactly what those puzzle pieces represent. And so we have European Flora here. That's the one that looks like a little flower. We have the Glossopteris, which is the first fossil that we mentioned on slide 1, and the Mesosaurus, and Signonathus, and Lystrosaurus. So if you look at here, what you're going to do is try to match up the different fossil types. So here you can see we have the Glossopteris fern, and you want to match it up with this one, and then also with this one, and with this one. So you want to make sure that when you click on the country, you grab and rotate the entire thing, and you want to try to match up the pieces. And they're going to be one giant continuous chain. So look for the end pieces, which would be South America and Australia for the Glossopteris plant. And then you're going to try to find all the in-between pieces to match it up. So for instance, if you know that South America is an end piece and you know that Australia is also an end piece, then you're going to need to move these guys around so that you can end up putting Africa and Antarctica in the middle. So you're going to move it around like so. And I'm just going to show you one to help you guys figure out how it works. So you're going to rotate it. See how the Glossopteris plant here and here matches up? You're going to rotate it around so that they actually do sit on top of each other like this. So you actually want to match up the coastlines. I'm not saying that this is correct. I'm just saying that this is a possibility for how it could work out. So you're going to rotate the pieces around. And ideally, you're going to want one giant landmass. So maybe that means you need to rotate Australia a little bit more so that it fits in really nicely, just like that with Antarctica. I don't know. That's just a possibility. It might not actually be the correct solution, but I just wanted to show you that you want one continuous chain for each of the fossil species. So find the end pieces and work your way from there. Okay? So that's what you're going to be doing for this part of the activity. And then after that, you have 3 questions to answer. So number 1, how did scientists use fossil evidence to prove that Pangaea existed? Because this was literally like one of the craziest ideas that anybody had ever heard at that time. The guy who came up with the idea, a lot of people ridiculed him and said that he was insane. And how does he expect that these giant continents can actually move across the surface of the earth? Like, they're made out of rock and they're extraordinarily heavy. But his name is Alfred Wegener. He had this idea that based on the evidence that he saw, that this was actually a possibility and that these continents can drift. So the whole idea is called plate tectonics and continental drift, where these giant land masses actually drift across the surface of the earth and can change their position over time. And again, that was like absolutely unheard of. And so many people doubted him. And so he had the evidence to back it up, though. And now his idea is well known by so many people. And his name, at least when it comes to geology and when it comes to eighth grade science and learning about it, Alfred Wegener is his name. He's German. And he is the singular person who is credited with this idea of continental drift and plate tectonics, where the Earth's crust is broken into pieces and they can move and shift around the surface of the Earth. It just goes to show that you just got to believe in yourself and take a look at the evidence and what it's saying. And evidence